Area is of measurement, you should always consider the positive quantity of the value of the determinant. Whenever all the points are given, even though if the value of the determinant is negative, area must be always considered as 3 only. When you get the value as negative, make it positive because you are calculating the area of a triangle. Any two columns have same values or any two rows have same value, the value of the determinants become 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In today's session, we are learning one of the application of determinants, that is how to find area of a triangle with the help of determinants. And also towards it, we are going to find out the equation of a straight line using the same formula about which we are going to find the area of a triangle also. Now here is a formula to find out the area of a triangle. We know that we need 3 vertices for a triangle. Thus, the area of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 is given by delta. We know that delta is a symbol denoted to find the value of the determinants. Thus, delta is equal to half of, so between the determinants we have x1, y1, x2, y2, x3, y3 and 1, 1, 1 in the last column. So these are the 3 vertices of a triangle. So this is the formula we are going to find out the area of a triangle. Now, when it comes to the value of the determinant, so we might get both positive and negative quantity. But when you are going to consider area, since area is of measurement, you should always consider the positive quantity of the value of the determinant. And whenever any points are unknown and only when the value of the determinant, that is the area of the triangle, is given. So for example, if x1, y1 is known, x2, y2 is known, x3, y3 is unknown. We doesn't know what is the point x3, y3, but we know the value of delta. Suppose if they give 3, then we have to take both plus or minus. So to calculate the point, whenever the value of the area is given, you should take both positive and negative quantity. But when you get the value as negative, make it positive because you are calculating the area of a triangle. So, and one more thing is, whenever the area of a triangle is 0, when you calculate the value of the determinant, if in case it is 0, that means the points are collinear. So, let's take an example. Find the area of a triangle whose vertices are 3, 8, minus 4, 2 and 5, 1. So, we know that delta is equal to 1 by 2, that is half of x1, y1. So, we will take 3, 8 here. Next, we have minus 4, 2 here. Next, we have 5, 1. And here we take 1, 1, 1 in the last column. So, this is how we are going to calculate. We can expand with the help of the first row. So, let me take the first row. We know this is plus, minus, plus. Let me take 3. 3 into, delete the column, delete the row. 2 ones are 2, minus 1 ones are 1. So, this is done. Next is minus 8. So, minus 8, delete the row, delete the column. Minus 4 into 1, minus 4, minus 5 into 1 becomes 5. The last one is plus 1. So, delete the column, delete the row, minus 4 into 1, minus 4, minus 5 2s are 10. So, this is how we expand with the help of the first row. So, we can also make the given determinant using the properties of determinant so that the last column become 1, 0, 0 by applying the elementary row or column operation, or simply we can expand using any one of the row or column. Now, let's see here. So, it is half. Now, here it is 2 minus 1, 1, 3 ones are 3. Minus 4, minus 5 is minus 9. So, 9 8s are 72, which is plus 72. Next is minus 4, minus 10 becomes minus 14. So, now we have here 72 plus 3, which is 75. 75 minus 14 becomes 61. So, therefore, this is 61 by 2. Square units. Because this is area, unit must be in square units. Next, find the equation of the line joining A 1, 3 and B 0, 0 using determinants and find K if D, K, 0 is a point such that area of a triangle ABD is 3 square units. Now I already said with the help of the equation of finding the area of triangle, we can also find the equation of a straight line joining any 2 points. Now what is the formula we generally use for this is, so we use determinant xy. So we take, let xy be any point on the line and the given points are x1, y1 and x2, y2. So these are the 2 points given, line joining points, that is 1, 3 and 0, 0 for this problem. And let me take one more point on the same straight line, that will be consider it as x, y, and another one is column, we take it as 1, 1, 1. Since all the points are on the straight line, what is the value of the determinant? It becomes 0 because they are collinear points. So we are finding the equation of the line joining given points. So we will take one more point to express it in the form of a general equation. That is why we take it as xy. x1, y1 is a given point and x2, y2 is also given point. And we don't write it as delta because the points are collinear, it lies on the straight line. I already said if the points are collinear, the area of the triangle is 0. That is why we take this general equation as 0. Now this formula helps us to find the equation of a straight line joining 1, 3 and 0, 0. Now let's see this. We take this as x, y and 1, 3. Next we take 0, 0. The last is 1, 1, 1. So this is equal to 0. Now consider the last row. Let me expand it with the help of a last row because we have 2 zeros in the last row. So first one is, the sign is here plus, minus, and here it is plus. So first one is 0. 0 into any of the determinant value is again 0. Second one is minus 0. Again any one of the determinant value is 0. The last one is plus 1. So 1 into, so this 1 we are taking. So delete the row and column containing 1. So we get 3 into x, which is 3x, minus y into 1, which is y, is equal to 0. So thus we get the equation as 3x minus y is equal to 0, or we can write y is equal to 3x. So this is the equation of a straight line joining the points 1, 3 and 0, 0. Now next there is one more sub question, that is find k if d k, 0 is a point such that the area of a triangle ABD is 3 square units. At first they have given these are the points of a straight line. Now they are telling that there is one more point k, 0. We need to find out the value of k so that the area of a triangle is 3 square units. So what is the formula we have? We have delta is equal to 1 by 2. So x1, y1, let me take it as 1, 3. Next x2, y2, let me take it as 0, 0. And the third one is k and 0. So here is 1, 1, 1. So you can alter any one of the point. You can write k, 0 here also, 1, 3 here also, or you can write 0, 0 in the first row also, so that you can make the simplification easier. And one more thing to note, that whenever the area is given, when you are finding an unknown point, I already said you should use both positive and negative sign. So delta value is plus or minus 3 because delta denotes area of a triangle. So this is equal to half. Now let me expand it with the help of the second row. So second row sign is minus, plus, minus. So this becomes minus 0. 0 into any determinant value 0. Next is plus 0. Then it is minus 1. So minus 1 means this one. Delete the column, delete the row. So we get 1 into 0, 0. Minus 3 into k, 3k it becomes. Now here this becomes plus or minus 6 because 2 into 3 is 6. 0, 0. Minus 1 into minus 3k becomes 3k. So this implies what? K value is plus or minus 2. So therefore, what are the points, or what is the third point? So the point is, so one is it may be 2, 0 or minus 2, 0. So this is the point, because for a point, it may lies in positive x-axis also or negative x-axis also. So therefore, here, whenever the area of a triangle is given, you should take it as both positive and negative. But whenever all the points are given, even though if the value of the determinant is negative, area must be always considered as 3 only. Only for the calculation purpose, to recognize the point, we are taking it as plus or minus 3. Thus, here we are getting the point as 2, 0 or minus 2, 0. Now, let's take few more questions. Find the area of the triangle with the vertices at the point given in each of the following. 1, 0, 6, 0, 4, 3. So, let me write delta is equal to half of 1, 0, 6, 0, 4, 3. And here 1, 1, 1. Simple. So, here it is, we have half. We can expand it through the second column. Second column is minus, plus, minus. So, let me take 0 first. 0, delete the row column in 6 ones are and 4 ones are, which is 0 again. Here it is plus 0, that becomes 0 again. Now, we have here minus 3. So, minus 3 means, so delete the column and row containing minus 3. Now, take the determinant value of the remaining. So, 1, 1, 6, 1 we have. If you take the determinant value, it is 1 ones are 1 minus 6 ones are 6. So, here we get half. So, minus 3 we get. So, minus 3 into minus 5. So, we get 3 5s are 15. So, we get 15 by 2 square units. So, the next question is 2, 7, 1, 1, 10, 8. So, let me take delta is equal to half of determinant 2, 7, 1, 1, 10, 8. So, we have 1, 1, 1. So, delta is equal to, you can expand with the help of any row or any column. So, let me take the first column. So, this it becomes 2 is, this is plus, minus, plus. So, take the determinant value of these. It is 1 ones are 1 minus 8 ones are 8. Next, it is minus 7. So, delete the row and column containing 7. Then it is 1 ones are 1 minus 10 ones are 10. Next is plus 1. So, 1 means 1 8s are 8 minus 10 ones are 10. So, now we have here half. So, here minus 7 becomes minus 14. So, minus into minus plus, it becomes 9 7s are 63. Next, we have minus 2 into 1 minus 2. So, now after solving this, we get it as half 47 here. So, therefore, the area is 47 by 2 square units. Next one, show that the points A, B plus C, B, C plus A, C, A plus B are collinear. So, how to show that 3 points are collinear? Whenever you get the area of a triangle as 0, that means the 3 points are collinear. So, let us find the area of the triangle for these points. Let me show that delta is equal to 0. If delta is equal to 0, then the points are collinear. So, now we have delta is equal to half of A, B plus C, B, C plus A, C, A plus B. And here we have 1, 1, 1. Now, since the value is not given, we have only algebraic values. I am applying here the elementary row or column operation. See the column 1 here. So, I will change the column 1 as the elements of column 1 plus column 2 plus column 3. So, therefore, the delta becomes here half of the first column element should be the sum of all. So, this becomes A plus B plus C plus 1. Similarly, this becomes A plus B plus C plus 1, A plus B plus C plus 1. And the remaining element you can write it as it is, B plus C, C plus A plus B, 1, 1, 1. Now, we have a common factor in the first column. So, I can take it outside. So, that becomes A plus B plus C plus 1. If you take a common factor outside, you are left with 1, 1, 1. Here, B plus C, C plus A plus B, 1, 1, 1. Now again using the properties of determinants, that is whenever any two columns are identical, that means any two columns have same values or any two rows have same value, the value of the determinants become 0. So therefore clearly I can write this value is 0. Since determinant value is 0, 0 into anything becomes 0. Therefore, if delta is 0, what can I consider here? I can clearly say that the points A, B, C are collinear. So, therefore, just conclude, therefore, A, comma B and C are collinear. So, when you show that the value of the determinant is 0 in the area of the triangle, that means the points are collinear. Next, find the values of K if area of a triangle is 4 square units and vertices are first one K, 0, 4, 0, 0, 2. So, let me write delta is equal to half of K 0, 4, 0, 0, 2 and here 1, 1, 1. So, clearly I can take the value of delta as 4 square unit, but you should take both positive and negative. And here we have 1 by 2. So, here we can expand. So, if you expand it with any one of the row or column, you can easily take this column to expand. So, the first two elements are 0. So, consider only this 2. So, delete the row, delete the column. So, then you have minus 2 because it is minus plus minus for the second column. So, it is 2 into K 1s are K minus 4 1s are 4. Now, here it becomes plus or minus 8 is equal to, so minus 2K minus into minus plus and here it becomes 8. So, we get minus 2K is equal to plus or minus 8 and here minus 8. So, we have two options here. Minus 2K is equal to 8 minus 8 or minus 2K is equal to minus 8 minus 8. So, this implies, so 8 minus 8 is 0 means this implies K is equal to 0 or, so if minus 2K is minus 16 then K is equal to, so here it becomes 2. Because both sides we have negative, it is 16 by 2 which becomes 8. So, therefore, K is equal to 0 or K is equal to 2 is the value of the point K, 0. So, therefore, the point may be 0, 0 or 2, 0. Next, minus 2, 0, 0, 4, 0, K. So, delta is equal to 1 by 2 minus 2, 0, 0, 4, 0, K. 1, 1, 1 and the area of the triangle is 4 only because we have two sub-question for the same question here, that is the area of a triangle is 4 square units. So, therefore, here also it is plus or minus 4 half, expand with this column. So, then it is plus minus plus. So, clearly we can write the first one as minus 2 into 4 minus K and the remaining are 0 and 0. Next is we have plus or minus 8 is equal to minus 8 again, minus into minus plus 2K it becomes. So, we have 2K is equal to plus or minus 8 plus 8. So, we get here 2K is equal to 8 plus 8 or 2K is equal to minus 8 plus 8. So, this implies what? K is equal to 2 or K is equal to 0. Again, these are the 2 points, that is, so one point may be 0, 0 and the other point may be 0, 2. So, therefore, the points are, so one is 0, 2 and another one may be 0, 0. Next. Find the equation of the line joining 1, 2 and 3, 6 using the determinant. I already said you the formula which we use to find the equation is x, y, 1, x1, y1, 1 that is 1, 2, 1, x2, y2, 1 that is 3, 6, 1 and we take the value as 0 because Since 3 points are on the same straight line, the value of the determinant becomes 0. So now here we can clearly expand now x into, so I am expanding with the help of first row, x into 2 ones are 2 minus 6. Next, minus y, because this is plus minus plus. Minus y means delete the column, delete the row. 1 ones are 1 minus 3 ones are 3. The last one is 1. 1 delete row, delete column. 1 6 are 6 minus 3 2s are 6 is equal to 0. So here this becomes 0. Now here we have here minus 4x minus 2 minus y becomes plus 2y is equal to 0. Or dividing throughout equation by 2, we get minus 2x plus y is equal to 0 or y is equal to 2x. So this is the equation of the straight line required. So this is one of the application of the determinant, that is to find a equation of a straight line or learning the area of a triangle with the help of determinants. We'll meet you in the next session with a new concept. Until then, keep watching, keep learning, keep exploring. Thank you.